continuity and differentiability. In coming episodes, you will learn about the important concepts of continuity, differentiability, and the relationship between them. You already know how to differentiate polynomials and trigonometric functions, and now in coming episodes, you will also learn how to differentiate the inverse trigonometric functions. Apart from that, you will also learn how to differentiate exponential and logarithmic functions. In the coming episode, you will also learn about the fundamental theorems in continuity and differentiability. And now, what do we mean by continuity? The English word continuity means uninterrupted or something which is without interruption. Suppose we draw the graph of a function, and if the curve so obtained is without any breaks, then we can say that this function is continuous in its domain. Or in other words, if we can draw the graph of a function in one stroke, which means without lifting pen from the plane of the paper, then we can say that this function is continuous. So let's try to understand the concept of continuity with the help of few examples. In our first example, now suppose if we have a function f of x where f of x is equal to 2 if x is less than or equal to 0 and f of x is equal to 3 if x is greater than 0. Now clearly from the definition of this function f of x, you can see that this function f of x is defined for all values of x, whether the value of x is less than or equal to 0 or x is greater than 0. So let's draw the graph of this function, and for that let's first draw a horizontal line as x-axis and a vertical line passing through center as y-axis. And now for the given function, if the value of x is less than or equal to 0, then in that case f of x is equal to 2. So that means if the value of x is less than or equal to 0, then the value of y is 2. So that means the graph of given function for x is less than or equal to 0 is a straight line which is parallel to x-axis. And if the value of x is greater than 0, then in that case the value of function f of x is equal to 3. Or in other words, y is equal to 3 when x is greater than 0. And again, the graph is a straight line which is parallel to the x-axis. And now if we carefully examine this graph, so here you can see if the value of x is close to 0 from the negative x-axis, or in other words, you can say if the value of x is close to 0 from the left hand side, which means if the value of x is minus 0.1 or minus 0.01 or minus 0.001 or further smaller, then in that case the value of y or f of x is equal to 2. In other words, we can say the left hand limit of the function f of x when x approaches 0 from the left hand side is equal to 2. And what about its right hand limit at x equal to 0? Now if you take the value of x as 0.1, 0.001 or further closer to 0, then you will find the value of y or f of x is equal to 3. So the right hand limit is equal to 3, and which means the left hand limit is not equal to right hand limit. And what's the value of the function at x is equal to 0? The value of function f of x at x is equal to 0 is 2. So here left hand limit is equal to the value of the function at the given point, but it is not equal to the right hand limit. So that means this is not a continuous function. Now let's consider one more function. Now in this function, f of x is equal to 2 where x is not equal to 0, and f of x is equal to 3 where x is equal to 0. Now if we draw the graph of this function, and if you look carefully at the definition of this function, then you will find that this function is defined for all values of x. And if we draw the graph of this function, so here you can see the graph will be a straight line which will be parallel to x-axis, as the value of y or the f of x is equal to 2 for all values of x, and f of x is equal to 3 where x is equal to 0. And here it is also clear that the left hand limit of f of x at x is equal to 0 is equal to 2, and also the right hand limit of the function f of x is also equal to 2. That means the left hand limit and the right hand limit at x is equal to 0 are equal, and the value of the function f of x at x is equal to 0 is 3, and which means the value of the function f of x at x is equal to 0 is not equal to left hand limit and right hand limit. So this is another example of a function which is not continuous at x equal to 0. So this again confirms that a function is not a continuous function if we cannot draw the graph of the function around a point without lifting the pen or pencil from the paper. And this function is the example of the same. And how do we write it mathematically? And this is also one of the important definition of continuity, according to which if f is a real function on a subset of real numbers and C be a point in the domain of f, then f is continuous at C if and only limit x approaches C, f of x is equal to f of C, or the value of the function at the point C. Or in other words, if the left hand limit and the right hand limit and the value of the function at x is equal to C exist and are equal to each other, then f is said to be continuous at x is equal to C. Or in other words, we can also say a function is continuous at x is equal to C if the function is defined at x equal to C, and if the value of the function at x equal to C equals the limit of the function at x equal to C. And what if the limit is not equal to the value at x is equal to C? In that case, we can say f is not continuous at C. Or in other words, we can say f is discontinuous at C, and C is called a point of discontinuity of f.